Hello, welcome to week 2, video 2 of Preppy Maths. This is the 10-week course that hopes to make you better. Well, it will make you better at high school mathematics. It will prepare you for the maths we do in high school. So aimed at age 9, 10, 11, 12, any students around that age. Parents, you can use it if you're home learning at the moment. Teachers, if you want to use this as a video, as a task, or to check on answers, please use this video and promote this. So here we go. Triangle areas. We're trying to mix it up. Every week have something to do with number, something to do with shape. And areas of triangles and triangles in general, almost obsessed with them in secondary school. We study a lot of triangles, and we're going to look at areas of triangles today. You might think you know how to do areas of triangles. That's fantastic. That's fantastic. But stick with this and see in terms of the mathematical thinking and problem solving we're going to do today. So what I need you to do is to try and get some squared paper. If you have centimeter squared paper or any type of squared paper, that's great. If you don't have squared paper, I wondered about this. You might be homeschooling at the moment. And so you can actually just take a ruler and a pencil and a plain piece of paper, and you can just do a bit of mindful dotting. I tried it myself. It took about 3 or 4 minutes, and I did manage to get centimeter dots, squared paper, just by me doing it with a ruler, spacing those dots pretty evenly. You can make your own squared paper, but if you can get some dotty square paper like that, it's a lovely resource to have for your maths learning. And all I want you to do is to think about a space maybe about 10 centimeters across and 10 centimeters down. So I've resized my screen here, so it's roughly centimeter squares. So we just call these square centimeters. About roughly 10 by 10. I want you to just draw maybe about 5 triangles. Now, triangles are 3-sided polygons. Polygon means any kind of 2-dimensional flat shape with straight edges. They're polygons, so 3-sided polygons would be a triangle. And just draw about 5 of them. You can either do your own, or you can kind of look at mine and think about copying mine, and we'll go through the answers from mine and maybe do some of your own later. So I'm going to draw about 5 triangles in this space. Okay, about 5 triangles in this space. I'm going to use my pencil and ruler if I was working on paper. But I'm going to try and draw roughly 5 triangles in this space. And so, take your time and just draw 5 triangles roughly in this space. I'm just realized I'm going to use a different color there because my lines are blue. But when you're using squared paper and line paper, just with these kind of geometric shapes, do try and stick as accurate as you can to the lines. As you can see here, I'm trying to be as accurate as possible. So there's one. I'm slightly off a little bit there. There's one. I'm going to draw 5. 1, 2, second one here. Let's go for one that looks a bit like this. Maybe go along there. So I'm just going to, spend a bit of time drawing 5 different triangles. Let me draw another one here. Let me draw another one here. There we go. And I'm trying to mix them up. So I'm trying not to draw triangles which look the same in any way. And this is the task we do in high school. We just say to students, just draw some triangles. Rather than give them triangles to find the area of, we often just say to students, just try and draw some triangles of your own, see what happens, see what you come up with. You come up with some really interesting shapes. There's 4 triangles, and then I'll draw another one in this space here. So see what you come up with. Okay, as I say, you can use these ones if you want to. You can just count the squares. I'll show you how to do that in a moment. There you go. So I've got 5 triangles. I'm going to find the area of these 5 triangles. Now, again, if that's enough for you, as a start point, just find the areas of these triangles, then pause the video and see if you can find the area of those 5 triangles, and then come back and check your answers in just a moment. Okay, just check your answers in just a moment. So pause the video. If that's enough for you, off you go. If you think you need a bit of support, a bit of help, a bit of a heads up because you've forgotten how to find maybe the area of a triangle. Let's have a go at this first one here. Now, counting squares. This is the interesting part. One thing I noticed in high school is that when we count the length of a line, some students make a bit of a mistake there. So if we're starting counting here, if we're starting counting in this bottom left corner of this triangle here, some students will make the mistake of starting there and counting 1, 2, 3, 4, 5, 6. So some students will make that mistake. It's quite a common mistake to make, even in the early stages of high school. The length of that line is not 6. The length of that line is 5 squares. And the mistake in counting comes from when you start to count the length of that line, your starting point is 0. 0, 1, 2, 3, 4, 5 squares. Alternatively, you could count it this way. You can just count the number of squares. There's 1 square there, 2, 3, 4, 5. That might be the safest way of doing it. But the mistake is when you start counting and you count the dots rather than the spaces. Now, I'll always talk to my students about fences and fence posts. So if I draw quickly a fence which has fence posts and fence sections, there are 4 fence posts, and in between those fence posts there are 3 fence sections. So although there are 4 fence posts, there are 3 fencing sections. So if you're counting the fencing sections, don't count the fencing posts, and vice versa. And in lengths of lines on squared paper, we are counting the fence sections, the spaces in between these squares. So be very careful. There might be 1, 2, 3, 4 fence posts, but there's only 1, 2, 3 fence sections. So the length of a line is the space in between these fence posts. It's a bit of a tip there for you, way of remembering it. So the length of that line in this triangle is 1, 2, 3, 4, 5 squares. There's 5 along there, 5 centimeters. And there's how many here? Count the squares if you want to. 1, 2, 3. 3. 1, 2, 3. 3. And to find the area of a triangle, yes, you may have remembered this. The way you do it is base times height divided by 2. You may have heard that phrase, base times height, then divide by 2. Why is it base times height divided by 2? Well, if you do base times height, if you do 5 times 3, you will end up with the area of a rectangle. 5 lots of 3. There are 5 lots of 3, 3, 3, 3, 3, 3, and there are 3 lots of 5, 5, 5, 5. There's 15 squares in that space, and hopefully you can see by cutting it with a diagonal all the way across there, this triangle is half of that space. So it's half. It's 5 times 3 divided by 2. So for the area of a triangle, what do we need to do? The area of this triangle I call capital A. It's 5 times 3 divided by 2. 5 times 3 is 15, divided by 2 is 7.5, and as we're using centimeter squares, that's square centimeter, so very well done if you got that one right. Next one, let's have a look at this one. What's this length across the base length, on the bottom, the base? 1, 2, 3, 4, and the height from the bottom to the top, 1, 2, 3, 4, so it's 4 and 4. And the area here, capital A, is 4 times 4. You can write divided by 2 like that, or to step up to high school maths, we'd quite like that as a quotient. A quotient. Sometimes people call this a fraction, but I'm going to try and use the correct word, quotient. It's a quotient. That's a oops a daisy. That's a quotient. So I'm going to try and use quotient. When we're doing some working, we do a division. It's called a quotient. 4 times 4 is 16 divided by 2, which is 8 square centimeters. Well done if you got that one right. My third triangle here, there's a base 1, 2, 3, 4, 5, 6, 7. Now, deliberately chosen this one because it's not got an obvious height. I've said base times height divided by 2, but when I say height, I mean vertical height, the vertical height. So if we've got a base that's horizontal like this, there's another word for you, horizontal. We've got a horizontal base. You remember that word from horizon, horizontal base. We need a vertical height, and a vertical height means you're going to go straight up. So what is the vertical height? What is the vertical height? Now, the vertical height in this case, I'm going to draw a little bit of a help on for us. This is the vertical height. This is the vertical height. You can see this is the vertical height inside the triangle here. How many squares is that? It is 1, 1, 2, 3 squares. So we've got a vertical height of 3. So it's important to remember that for a triangle, it's base, if there's a horizontal base or a base, times the height, then divide by 2, using that quotient notation again. 7 times 3 is 21 divided by 2, 10.5. And we're using square centimeters. So excellent and very well done if you got that one right. Now this one, I've chosen this one for a reason. You may have realized base, horizontal base. Now when I use the word base, you might think it's got to be at the bottom. Well, does it have to be at the bottom? Well, in this case, no. Look, that horizontal, what I'm going to call the base, is actually at the top. And the vertical height sometimes means, people think it means going up. But you can see here, my height is going to actually go down. So what's my base length? I'll draw some arrows on here just to kind of help you, hopefully. My base length, I'm going to say, is across there. That's going to be my base length, my length of my rectangle. And my height is actually going to be there, going down. So a little bit of an orientation thing. That orientation means how a shape is turned. It doesn't have to be turned one way or another. You can visualize it as a base and a height, and then you might think that one looks upside down. Well, it's not upside down, it's just been turned. It just looks a bit different. So yeah, my base does not have to be at the bottom. What is my base length here of this triangle? 1, 2, 3, 4 squares. And what is my height, which happens to be going down? It's 1, 2, 3, 4. So again, here my area will be base times height divided by 2, which is 8 square centimeters, 16 divided by 2. So these two triangles actually have equal area, and we're going to come back to that in a moment. These two triangles, although they don't look exactly the same, they have equal area. They have equal area, which is interesting. So there we are. There's our first 4 triangles. Now this one, I chose this one, and it's a bit trickier. So we're going to have a look at this one here, because lots of students, when they join high school, know how to find the area of a triangle. They say base times height divided by 2, or whichever rule that you've learned in primary school. But then we show them problems like this kind of triangle. And you say, well, okay, where is your base? Which one of those sides would you like to pick as your base? And is it that one? And if it's that one, they're the base. Well, how long is that? Some students make the mistake of just counting the squares. 1, 2, 3, 4, 5, 6, 7. Well, 7 is the length from here to here. It's not the length across there, because you can see it slants up a little bit. It's a bit longer than 7. So how do we find the base length of that triangle if we're going to use base times height divided by 2? And we get a bit stuck. And we realize sometimes that our rules that we've learned to find the area of a triangle are not enough, because we don't know what these base lengths are, and we don't know what the vertical heights are. So we're stuck. So we need a bit of problem solving, a bit of mathematical thinking, beyond just learning the formula for a triangle. So let's have a look at this triangle again, and let's have a look at it in a bit more detail. What I'm going to do is I'm going to make a copy of this one just down here, because I'm going to need to have a little bit more space, I think. Now, here's one thing that I will help you with in terms of counting, and counting on squared paper. Watch this. I want to draw this diagonal line from the bottom left up to the top there. I want to draw that diagonal line. I want to draw it here. How do I copy that diagonal line and make sure it's perfectly accurate? Let's see. I'm going to start here. I'm going to count across. I'm going to go across 1, 2, 3, 4, 5 squares to there. And then I'm going to go up 1, 2, 3, 4 squares. So that was a long 5 and up 4 to draw my diagonal. A long 5 and up 4 to draw my diagonal. So how does that help me? Well, now I can just draw my new diagonal because I'm repeating a drawing of this shape. I'm going to start here and I'm going to go along 1, 2, 3, 4, 5 squares and up 1, 2, 3, 4. Now that is actually a tricky skill. That is actually a tricky skill. A number of high school students get a bit caught out in how to do diagonal lines by counting squares and making sure you're going along and up or along and down the correct number of squares. And this will all feed into your ability to do some harder mathematics that's coming up in terms of geometry and graphs work. So being able to count those squares and draw diagonal lines is really important in high school. Now, if I want to draw my line down here, I'll pause the video. If you think that's enough now to redraw my triangle, you haven't drawn my triangle yet, I want you to draw this one. Have a go at copying this onto your squared paper or your personally made up squared paper. Have a go at drawing that one. Pause the video now. Okay, so if you have a good go at this, you can see that from the top to the bottom right, I've got to go along 1, 2 and down 1, 2, 3. I could have gone down first and then along, but in mathematics we tend to go along first. So along 0, 1, 2 and down 1, 2, 3. So I've got to draw a line here that's along 2 and down 3. So I start my point here with my ruler. I go along 2 and down 3. Hold the ruler really carefully. Make sure you're in the right place and then draw the line in. There we go. And this one should be easy to do, but I'm going to double check it. To draw this bottom line, it's along from the bottom left 1, 2, 3, 4, 5, 6, 7 and up 1. So that slant is along 7 and up 1. 1, 2, 3, 4, 5, 6, 7 and up 1. Yeah, that confirms I got it right. There we go. Lovely. I'm very happy with that. We're going to come back in the 10-week course and do more of this type of stuff because this type of counting and thinking really will come up more again and again in mathematics, in geometry work. So that's a real skill. So just to recap, what we've done is we've looked at areas of triangles. We've used base times height divided by 2 to find the area of these triangles. We've explained why we divide by 2 and why it's base times height. It's kind of half the area of an enclosed rectangle. Maybe I should have shown that here. Look, 7 times 3 is 21. If you do 7 times 3, you get the area of a rectangle all the way across there. 7 3s, 21 squares. And hopefully you can see in this section, that part of the triangle is half of that rectangle, and that part of the triangle is half of that rectangle, which is why overall we half it. So we've done base times height divided by 2. We've explained why it's base times height. We've explained why it's divided by 2. We've done some calculations and some working. But then we've got this triangle, and we seem to have failed. So I've copied the triangle below, and we're going to do a lot more work with this triangle. Let's try and work out the area of this triangle. If you think you can do it, pause the video. If you think you've worked it out, in my counting of longs and ups, that may have given you a big hint. Counting along and up to draw those diagonal lines may have given you a big hint, and you might be able to do it now. So off you go, see if you can do it. If you still need some help with this one, I'll give you some hints. Here we go. Now those alongs and ups may have given some of you a hint, but let's have a look. My first line I drew was from the bottom left to the top. And I went along 1, 2, 3, 4, 5 and up 1, 2, 3, 4. And I'm going to actually draw some dotted lines here. And I'm going to draw a dotted line across there. Now you might remember me kind of enclosing a triangle within a rectangle before. I'm going to continue. I'm going to continue that horizontal line to that point. I'm going to continue my dotted line down that point. Now, if this is giving you enough of a hint now, again, pause the video and see if you can carry on from there and tell me the area of that pink triangle. Let's continue with the hints. There. I'm going to fully enclose this with horizontal and vertical lines. Okay, so I've used that word horizontal, horizontal, that's horizontal, vertical, and I've used the word orientation. Orientation, that's how something is oriented. So if we turn something, it changes its orientation. Okay, so orientation. So three words there to remember for mathematics. And I've used horizontal and vertical lines to enclose this triangle completely. Now, if that's enough of a hint, have a pause and see what you can do. Here's a further hint for you. I think I can find the area of that triangle. I think I can find the area of that triangle. And I think I can find the area of that triangle. Again, pause if you think that's enough. Okay, so if you've had a good go at this now, I'm just going to I think I can find that triangle. Wasn't so confident doing that one, was I? Here we go. So this one here, let's try and find the area of this triangle. It's one of those ones where the base is kind of on the top and the height is down, but I can think of the orientation. I've got that vertical height. That means that must be 90 degrees. The vertical height, I didn't mention that earlier on, but that must be 90 degrees. How many squares across here? 1, 2, 3, 4, 5. How many squares down? 1, 2, 3, 4. So I think the area of that triangle in there is 5 multiplied by 4 divided by 2, which is 20 divided by 2, which is 10. I'll put the units in a moment. I think this one here, we counted across here, didn't we, when I did my diagonal line? 1, 2, 3, 4, 5, 6, 7, and up 1. That's also the vertical height. So I think the area here is 7 multiplied by 1 divided by 2, which is 3.5. And I think the area here is 2 multiplied by 3 divided by 2. And I think that's 3. So now I've found the area of these triangles. And in mathematics, this is often a skill we use. When we're trying to find something and we're not sure, we find anything that we can find, what we do know. So I want to find the area of that pink triangle, and I'm not sure. So I don't find the area of the pink triangle. I find the area of 3 different triangles. You think that's a very strange way of working, but hopefully you can see now how to work out the area of this pink triangle. If you think you can, pause the video again. And if you think you've had a really good go at it, well done, and let's have a look. Well, I think I now know the entire area of this whole rectangle. So the area of the entire rectangle, I'm going to use that kind of, the area of the entire rectangle, I think that is 7 multiplied by 4, 28. It's 7 across, you see, 1, 2, 3, 4, 5, 6, 7, and it's 1, 2, 3, 4 vertically. So I think the area of the whole triangle, of the whole rectangle, or maybe I should write that. I'll put the word rectangle. I think the area of the large rectangle, that might be clearer, is 7 multiplied by 4 is 28. Now, often we see in high school students, as soon as we ask the high school students to find the area of a rectangle, just after finding the areas of lots of triangles, they will divide by 2. Because they've been finding the areas of triangles, they think they divide by 2. But you've got to remember, maths rules work for certain things. They don't work universally. So the rule for an area of rectangle is still the whole base length multiplied by the height. You don't need to divide by 2 just because you've been finding areas of triangles. So don't forget, area of a rectangle is just 7 times 4, in that case 28. So the whole of that rectangle, big rectangle, is 28. But I've just worked out the area of the 3 blue parts. And I think if I use subtraction, that will be the key. If I use a subtraction now, I can subtract the area here. I can subtract the 10, the 3.5, and the 3. So the area of the triangle, the area of my triangle, will be that 28, the area of the whole, subtract the 10, subtract the 3.5, and subtract the 3. If you subtract these areas, the bit you'll be left with will be the area of the triangle. I'll color code that up just so you can see where I've got that from. That 10 is there. Let's not use that. Let's use purple. That 3.5, I'm taking away the 3.5, and I'm taking away or subtracting the 3 over there. I'm taking away or subtracting the areas of these 3 triangles, which I could find the area of because I could find their base and vertical height. And that is a neat little method, a neat little trick in mathematics, which will tell me the area overall of my triangle. What is it? Let's check it out. What's 28 take away 10? That's 18. And then subtract 3.5 and subtract 3. 18 take away 6.5 will be 11.5. I think that's right. I think 11.5 square centimeters. Now, if you did that without any help at all, that's amazing. If you got a few hints, really, really good. But don't forget, we're in week 2 here of this, building your confidence for high school maths. And so if you needed a few hints on that one, no problem, absolutely no problem. But we'll get better and better and better at this problem solving type thing. I'm just checking my working there. I've got to subtract a total of 16.5, and that's right, that is correct, isn't it? 11.5 square centimeters. So just to review, base times height divided by 2 for triangles works really, really well. It does, as long as you use vertical heights. These heights do have to be vertical. Yep, these vertical heights here. Okay. But then suddenly we get a triangle where we can't easily find the base, and we had to use a bit of mathematical problem solving, a bit of thinking, a bit of scripting, quite a lot of working, and quite a clear diagram. Communicating your maths is hugely important, so that diagram is really important. You can see I've got a diagram, clear diagram. I've got working here, working here, working here, and then I'm explaining my communication. I'm being very careful to try and communicate what I'm doing with a diagram, with maths working, and with some language as well. Really, really important. Okay, so if you'd like to have another go at finding an area of any type of triangle, this is how easy it could be now. All you've got to do is take your squared paper, if you've managed to get hold of some, or just draw some out yourself. It doesn't take too long on plain paper. You can literally just test yourself at any time now, and you can just draw a few diagonals, making sure you don't create any kind of any vertical heights and bases, and you can test your skill at that problem solving. So there's another one. I'm going to run through the answer to this one very, very quickly in a moment, but have a go at that one. What's the area of that triangle there? Pause the video. Right, here we go. Now I'm going to go through really fast through this one now, just to finish off the video. I'm very well done for sticking through this. Okay, I'm going to enclose this triangle with horizontal and vertical lines. I only go as far as I need to. In maths, a sketch like this, I would definitely use a ruler and pencil for my triangle. But sketching around a little bit in mathematics, nothing wrong with that. There's nothing wrong with that at all. So this is 3 times 1, 2, 3, 4, 5, 6. That's 3 times 6 divided by 2, which is 18 divided by 2. That's 9. So that one there is 9. This one, 1, 2, 3, 4, 5, 6, 7, 7, and that's 2. So that's 7 multiplied by 2 divided by 2. That's 14 divided by 2 is 7. So that one there is 7. And this one is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So that's 4 multiplied by 8 divided by 2. 4, 8, 16, 32. Divided by 2 is 16. So that one there is 16. My entire rectangle will be 1, 2, 3, 4, 5, 6, 7 divided by 7. 1, 2, 3, 4, 5, 6, 7, 8. So my entire rectangle will be 7 times 8, which is 56. I don't divide by 2, it's a rectangle, don't forget. I've made the mistake myself before. And I'm going to subtract 16. I'm going to subtract 9. I'm going to subtract 7. So I'm going to subtract a total of 16 and 9 is 25 plus 7 is 25, 32. And so that would be 24. I think that's going to be 24 square centimeters. You can double check my working there. 24 square centimeters, I think. 7 eighths, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 7 eighths are 56. 4 eighths, 4 eighths are 32 divided by 2 is 16. 3 sixes are 18 divided by 2 is 9. 7 twos are 14 divided by 2 is 7. And we subtract 16, 9, and 7. That's subtracting a total of 32. 56 take away 32 is 24. Yes, I just double checked my answer and I believe that's correct. Amazing job if you got that right. Well done. Please, I forgot to always say this in this, but please do click like, subscribe to this to get updates of this 10-week course as you go through. But it really helps me if you subscribe. I get some more data. I can see what's happening. I can see who's taking part in this. But 10 weeks, stick with it and it will improve your high school maths. And I'm going to do a pen drop. Thank you. Bye-bye.